Good morning, students. So in the last lecture we have studied about sewers and sewerage system. So in order to design the sewers and the drains, it is necessary to estimate the quantity of sewage discharge and stormwater discharge that are likely to enter the sewer or drains. And the methods for estimating the maximum sewage discharge were discussed in the last lecture. So here we will discuss the methods to estimate the maximum rate of storm runoff, or that is known as peak drainage discharge. Okay, so here we have to calculate the stormwater flow which is going to flow through the sewer. So we know that when a rain falls on certain area, a part of it is intercepted by the soil, that is infiltrated into the soil, a part of it is evaporated, and the remaining water will flow overland towards the valley as storm runoff, as runoff water. And that surface runoff resulting after precipitation contributes to stormwater. So stormwater means it's actually the runoff water. So this runoff water contributes as stormwater. Okay. So for designing the sewers and the sewerage system, we have to calculate the stormwater which is going to flow through that sewer. Quantity of stormwater has to be calculated. And the quantity of stormwater reaching to the sewers or drains is very large as compared with the sanitary sewage, because we cannot predict the quantity or amount of rain which is going to fall on our area. So this amounts, usually the quantity of stormwater will be very much high than that of sanitary sewage, and we have to calculate that quantity. And the factors which are affecting the quantity of stormwater flow are area of the catchment, slope and shape of the catchment area, porosity of the soil, obstruction in the flow of water as trees, fields, gardens, etc. Initial state of catchment area with respect to wetness, then intensity and duration of rainfall, atmospheric temperature and humidity, number and size of ditches present in the area. Okay, so these are some of the factors which are affecting the quantity of stormwater flow. Next is measurement of rainfall. So the rainfall intensity could be measured by using rain gauges. Okay, that you have studied in hydrology about the rain gauges, measurement of rainfall, etc. And recording the amount of rain falling in unit time. That is done through these rain gauges. Okay, and the rainfall intensity is usually expressed in mm per hour or centimeter per hour. And the rain gauges used can be manual recording type or automatic recording type of rain gauges. And methods for estimating. So here we have to calculate or estimate the quantity of stormwater. So for that there are mainly two methods. One is rational method and another one empirical formula method. And this rational method is usually used for smaller areas. If the area under study is very small, we can use rational method. And the area where we have to design the sewerage system is very large, we can go for empirical formula. Okay, so in both the above methods, the quantity of stormwater is considered as function of intensity of rainfall, coefficient of runoff, and area of catchment. So next we have to discuss about coefficient of runoff, time of concentration, etc., which are affecting or which are influencing the stormwater discharge. Okay, so first we can discuss about time of concentration. Okay. So time of concentration means it is the period after which the entire catchment area will start contributing to the runoff. It's known as time of concentration. Okay, so time of concentration means it is the period after which the entire catchment area contribute to the runoff. For example, consider this is the catchment area under consideration. അപ്പോൾ ടൈം ഓഫ് കോൺസെൻട്രേഷൻ എന്ന് പറയുന്നത് ഈ ഒരു കാച്ച്മെൻറ്റ് ഏരിയയിലെ എല്ലാ പോയിൻറ്റും റൺ ഓഫിന് കോൺട്രിബ്യൂട്ട് ചെയ്യാനെടുക്കുന്ന ടൈം, അതാണ് ടൈം ഓഫ് കോൺസെൻട്രേഷൻ. ഓക്കെ, അതായത് ഇതാണിപ്പോൾ റൺ ഓഫ് വാട്ടർ. അപ്പം ഇതിപ്പം മോസ്റ്റ് റിമോട്ട് ഏരിയ ആണെങ്കിൽ ഇവിടുത്തെ വാട്ടറും കൂടെ ഈ റൺ ഓഫിലേക്ക് ജോയിൻ ചെയ്യാൻ വേണ്ടി എടുക്കുന്ന ടൈം, that is known as time of concentration. So time of concentration means it is the time or the period after which the entire catchment area will start contributing to the runoff. ആ catchment area എല്ലാ പോയിൻറ്റും റൺ ഓഫിലേക്ക് കോൺട്രിബ്യൂട്ട് ചെയ്യാൻ എടുക്കുന്ന ടൈം, that is known as time of concentration. And its time of concentration is also defined as the time required by the water to reach the outlet from the most remote point of the drainage area. Okay, so that is known as time of concentration. And the rainfall with a duration lesser than the time of concentration will not produce maximum discharge. അതായത് ടൈം ഓഫ് കോൺസെൻട്രേഷൻ, ഇതാണ് ടൈം ഓഫ് കോൺസെൻട്രേഷൻ, മാക്സിമം ഡിസ്ചാർജിന് എടുക്കുന്ന ടൈമാണ് ടൈം ഓഫ് കോൺസെൻട്രേഷൻ. അപ്പോൾ ടൈം ഓഫ് കോൺസെൻട്രേഷനിലും കുറവാണെങ്കിൽ ഡിസ്ചാർജ് മാക്സിമം ആയിരിക്കില്ല, മാക്സിമത്തിനാൽ കുറവ് ഡിസ്ചാർജ് ആയിരിക്കും. The rainfall with a duration less than time of concentration will not produce maximum discharge. അതേപോലെ runoff may not be maximum even when the duration of the rain is more than that of time of concentration. Time of concentration-നെക്കാളും കൂടുതൽ ഡ്യൂറേഷൻ ആയാൽ റെയിൻഫോൾ ഇൻറ്റൻസിറ്റി മാക്സിമം ആവില്ല. കാരണം ഡ്യൂറേഷൻ കൂടുന്തോറും എന്ത് പറ്റും, ഇൻറ്റൻസിറ്റി ഓഫ് റെയിൻഫോൾ കുറയും. അപ്പോൾ അതുകൊണ്ട് അപ്പോഴും ഡിസ്ചാർജ് മാക്സിമം ആവില്ല. അതായത് ഡിസ്ചാർജ് മാക്സിമം ആവുന്നത് ടൈം ഓഫ് കോൺസെൻട്രേഷൻ. വെൻ ടൈം ഓർ ഡ്യൂറേഷൻ ഈസ് ഈക്വൽ ടു ടൈം ഓഫ് കോൺസെൻട്രേഷൻ ഡിസ്ചാർജ് വിൽ ബി മാക്സിമം. ഓക്കെ, അതായത് ഡ്യൂറേഷൻ ടൈം ഓഫ് കോൺസെൻട്രേഷനേക്കാളും ഡ്യൂറേഷൻ കുറവാണെങ്കിൽ ഡിസ്ചാർജ് മാക്സിമം ആവില്ല. അതുപോലെ ടൈം ഓഫ് കോൺസെൻട്രേഷനേക്കാളും കൂടുതൽ ഡ്യൂറേഷൻ ആയാലും ഡിസ്ചാർജ് മാക്സിമം ആവില്ല. കാരണം ടൈം ഓഫ് കോൺസെൻട്രേഷനേക്കാളും കൂടുതൽ ഡ്യൂറേഷൻ ആകുമ്പോൾ റെയിൻഫോളിൻ്റെ ഇൻറ്റൻസിറ്റി കുറയും, അപ്പോൾ ഡിസ്ചാർജും കുറയും. അപ്പം ഡിസ്ചാർജ് മാക്സിമം ആവുന്നത് വെൻ ഡ്യൂറേഷൻ ഈസ് ഈക്വൽ ടു ടൈം ഓഫ് കോൺസെൻട്രേഷൻ. ഓക്കെ, the runoff is maximum when the duration of rainfall is equal to the time of concentration, and it is known as critical rainfall duration. Okay, and the time of concentration equal to sum of inlet time and time of travel. Time of concentration calculated as the sum of inlet time and time of travel. So inlet time means, so time of concentration is equal to inlet time plus time of travel. Inlet time is the time required for the rain in falling on the most remote point of the tributary area to flow across the ground surface along the natural drains or gutters up to inlet of sewer is called inlet time. ഓക്കെ, അപ്പോൾ സീവറിൻ്റെ ഇൻലെറ്റ് വരെ എത്താൻ റിമോട്ട് ഏരിയയും കൂടെ കൺസിഡർ ചെയ്യുകയാണെങ്കിൽ അവിടെയുള്ള വാട്ടറിനും കൂടെ സീവറിൻ്റെ ഇൻലെറ്റിലേക്ക് എത്താനുള്ള ടൈമാണ് ഇൻലെറ്റ് ടൈം എന്ന് പറയുന്നത്. ഓക്കെ, അപ്പം ടൈം ഓഫ് കോൺസെൻട്രേഷൻ പറയുന്നത് ഇൻലെറ്റ് ടൈം പ്ലസ് ടൈം ഓഫ് ട്രാവലാണ്. ടൈം ഓഫ് ട്രാവൽ എന്ന് പറയുന്നത് ടൈം റിക്വയർഡ് ബൈ ദ വാട്ടർ ടു ഫ്ലോ ഇൻ ദ ഡ്രെയിൻ ചാനൽ ഫ്രം ദ മൗത്ത് ടു ദ പോയിന്റ് അണ്ടർ കൺസിഡറേഷൻ. അപ്പോൾ ഡ്രെയിൻ ചാനൽ, ദിസ് ടൈം ഓഫ് ട്രാവൽ ഈസ് ആക്ച്വലി ചാനൽ ഫ്ലോ ഇൻ ദ ഫോം ഓഫ് ചാനൽ ഫ്ലോ. ദറ്റ് ഈസ് ദ ടൈം റിക്വയർഡ് ബൈ ദ വാട്ടർ ടു ഫ്ലോ ഇൻ ദ ഡ്രെയിൻ ചാനൽ ഫ്രം ദ മൗത്ത് ടു ദ പോയിന്റ് അണ്ടർ കൺസിഡറേഷൻ. ചാനൽ മൗത്തിൽ നിന്ന് നമ്മൾ കൺസിഡർ ചെയ്യുന്ന പോയിന്റ് വരെ ട്രാവൽ ചെയ്യാൻ എടുക്കുന്ന ടൈമാണ് ടൈം ഓഫ് ട്രാവൽ. ഓക്കെ, സോ ഇൻലെറ്റ് ടൈം പ്ലസ് ടൈം ഓഫ് ട്രാവൽ. അപ്പോൾ ഇൻലെറ്റ് ടൈം എന്ന് പറയുന്നത് ഫ്ലോ പീരീഡും ഇതൊരു ചാനൽ ഫ്ലോ ആണ്. ഓക്കെ, സോ the inlet time Ti can be estimated using relationship similar to the following. These coefficients will have different values for different catchment. These coefficients have different value for different catchment, and Ti is equal to 0.884 L raised to 3 divided by H into H raised to 0.385. Okay, so these parameters are not clear in this PPT, so I will share the PDF, or also in textbook you can see this equation, okay, clearly. I will share the PDF. So this is the equation for calculating inlet time. Okay, so I will repeat. Inlet time Ti is equal to 0.885 Lq by H, the whole raised to 0.385, whole raised to 0.385. That is the equation. Where Ti means time of inlet or inlet time in minutes. L means length of overland flow in kilometers from critical point to mouth of the drain. Then H is the total fall of level from the critical point to mouth of drain in meters. So this is the equation for calculating inlet time. Then time of travel means it is the time required by the water to flow in the drain channel from the mouth to the point under consideration. It's called time of travel. So it's actually channel flow. So you have studied in fluid mechanics about open channel flow, pipe flow, etc. So this equation will be for channel flow. So equation, that is time of travel is equal to length of drain divided by velocity in the drain. So this is the equation for calculating time of travel. So time of concentration is the sum of inlet time plus time of travel. Okay, so the next parameter under consideration is coefficient of runoff. So the total precipitation falling on any area is dispersed as percolation, evaporation, storage in ponds or reservoirs, and surface runoff. That is, the rainwater which is coming on our earth's surface will be infiltrated into the ground, that is percolated into the soil. Then some part may be evaporated, and some portion of that rainwater may be stored in ponds, reservoir, etc. And the remaining part will flow as a surface runoff. And the runoff coefficient, it is indicated by the letter capital K. Runoff coefficient is a dimensionless coefficient, and it is relating the amount of runoff to the amount of precipitation received. So K, that is runoff coefficient, is equal to runoff divided by precipitation. That is a ratio between amount of water which is known as runoff to precipitation amount. That is the runoff coefficient, and it is a dimensionless parameter. It is a larger value for areas with low infiltration and high runoff payments, and lower for permeable well vegetated areas. That is, when infiltration, if the soil will be having low infiltration, the runoff will be high. That is, greater the imperviousness of an area. That is, if the area is impervious or impermeable, lesser will be the infiltration. Okay, that is, if the soil is impervious or impermeable, infiltration will be lower, lesser will be infiltration. So hence greater will be runoff. Okay, when infiltration reduces, runoff will be more. Okay, so at that case K will be high, because K is equal to runoff by precipitation. Okay, so that is it is a large value, that is K is higher for areas with low infiltration and high runoff, and this K is lower for permeable. That is, if the soil is permeable, what will happen? The infiltration will be more will be infiltration, and hence lesser will be the runoff. So this K will also reduces. Okay, so remember this equation, coefficient of runoff K is equal to runoff divided by precipitation. Okay, so if the imperviousness of an area is more, then this runoff coefficient will be more, and if the soil is less impermeable or less impervious, K will also be less. Okay, and the value of K increases as imperviousness of the area increases. That is, greater is the imperviousness of an area, lesser will be the infiltration, and hence greater will be runoff. So this table shows values of runoff coefficient K for various surfaces. That is, for watertight roof surface it is 0.7 to 0.95, and for asphalt pavement it is 0.85 to 0.9. That is, these are highly impervious, so greater will be the runoff coefficient. Since this watertight roof surface, then asphalt pavement etc. is highly impervious, there will be lesser infiltration and greater will be runoff. Okay, and for these type of areas, that is wooden land, then parks, lawns, gardens etc., this will be somewhat more permeable, so infiltration will be more, and hence K will be less. So here lesser value. Okay, so that is a variation of runoff coefficient. Next, values of runoff coefficient for different types of localities. So it's also, if it is permeable, K will be lower, and if it is impermeable, K will be high. That is the variation. Next, we can discuss about the overall runoff coefficient for the catchment area. So the total area A, that is the total area of the catchment, total area A of the district can be considered to be made up of smaller areas A1, A2, A3 extra up to AN. That is, the total area A is divided as A1, A2, A3 extra up to AN, having runoff ratios or runoff coefficient as K1, K2, K3 extra up to Kn respectively. Then runoff ratio. Okay, so in that case, that is, if the entire area is divided into small areas and each area has a different runoff coefficient, we can calculate the effective runoff coefficient or coefficient of runoff for the entire area by using this equation. That is, K is equal to K1A1 plus K2A2 plus K3A3 plus extra up to KNAN divided by A1 plus A2 plus A3 plus extra up to AN. That is sigma Ka divided by sigma A. Sigma A means total area A. Okay, so this is the procedure how we calculate coefficient of runoff if the total area is divided into small area and each area has different values of K. Okay, so that is the procedure. In problem, this type of questions will be asked. Okay. So these are the various parameters which are affecting stormwater drainage or quantity of stormwater drainage. So in the next video, I will put the equations, empirical equation and rational equation for calculating stormwater drainage. Thank you.